All right, welcome in everybody. Here we go with our discussion of statistics. So I kind of looked things over and looked where we were in the class, and I made some decisions about what I was going to cover today. So remember, we only meet so many times. Like normally for the semester, if it was on ground, we'd be meeting somewhere in the neighborhood of 75 hours, 72 hours, somewhere around in there, that we would be meeting throughout the semester. That's a lot more time we have to talk about stuff versus now where we're meeting for like half that time, right? Which is still a lot compared to some of my classes. I have a class that just started on Tuesday. That class meets for a total of like 12 hours. So that one's kind of wild. But bottom line is that means I have to pick and choose what I'm going to talk about in class. I can't say all the stuff that I would normally say because I have, half the time to say it. So I kind of readjusted what I wanted to go over. We're about to enter probably two of the most important topics for this entire course. One is confidence intervals and the other is hypothesis testing. And they both are rather complex. They take probabilities to understand. They both use probabilities like extensively. Not so much that you're going to be calculating probabilities, but to understand what those probabilities imply about the problem that we're working on. So I want to make sure that, I don't just throw it at you in the last 2 weeks and say, here you go, do you get it? Because what I know is when students are first introduced to confidence intervals, when students are first introduced to hypothesis tests, they don't get it at first. Like, a handful of you will just watch it and go, okay, that makes sense. But most of you, there's subtleties going on. There's nuances. There's like layers of understanding how these problems work. And it takes a little bit of time for all that stuff to sink in and actually start to make sense, right? It's one of those things where I see students who can immediately memorize how to do problems. They can immediately memorize how to do a hypothesis test. But then when I say, okay, well, interpret that for me. Explain to me what you just did with the hypothesis test, and they kind of can't do it. They're like, well, I memorized what to do in StatCrunch, and it told me to do this, so now I reject the null. Okay, but what does that mean about our data that we're trying to understand? And they go, I don't know. So that is completely missing the point. It's completely useless for you to be able to calculate something in StatCrunch, but have no idea what that thing means, right? Just think for a minute, like, how would that make you better being able to do that? And the answer is it doesn't, right? So I want to spend enough time with confidence intervals and hypothesis tests that you understand them, because you're going to have to explain them in your project. And, I'm giving a lot of freedom on the project about what you include and what you don't include, right? So if one group might show me a bunch of histograms and box plots and bar charts, and if they do a great job with it, I'm not going to say, well, you -3 because you didn't show me a pie chart or something, right? Or there may be another group that uses pie charts and doesn't use certain things. I'm giving you some freedom that if you do a good job with your data and you use the tools correctly, I'm going to give you some points. But there are certain things that absolutely should be included. Histograms, right? Some summary statistics, some visuals, and then things you absolutely should have in your project: confidence intervals and hypothesis tests. If you're not including those and discussing them, I'm going to assume that you only did about half the class, right? Because those are two huge topics. There's no reason not to be using those. So with statistics, it's hard because I'm giving you this leeway to do what you think is best. But again, remember, it's your opportunity to show me what you learned. And so you definitely want, at least one and maybe more confidence intervals in there, and at least one and maybe more hypothesis tests that you can explain to me what it means, so that when I'm watching it, I can tell that difference between this and the truth is it comes through, right? It's almost hard not to see it, but it's like, okay, this person just memorized what someone said in a video and can reproduce it, but doesn't really understand the statistics. This person over here totally understands the statistics, and they can interpret it and make sense of it, and because that's what you're going to be doing in the real world. If you're in this class, the assumption is that whatever degree you're chasing said you need statistics, which means you will occasionally probably need to use some statistics, or at least be able to understand statistics and make good decisions based on those statistics. Well, the calculation part doesn't really help you there. In fact, calculation is really not that valuable anymore, because your employer can get StatCrunch for $15 a month. That's a whole lot cheaper than an employee doing calculations, right? So the whole reason the value in statistics comes from taking what the numbers that the computer is crunching and being able to make a recommendation to your job or your research and saying, here's what we need to do next week according to our statistics, or here's how we need to make changes and decisions based on what StatCrunch is showing me, right? So remember, it's all about the interpretation. If you can crunch numbers and you can punch buttons on a calculator, it's a nice little fun exercise, but it's essentially useless. Like you'll need to be able to do that. But if that's all you can do, you might as well not know any statistics at all, right? You gotta have that interpretation piece along with it. I am getting certain groups that are coming to me in the Zoom meetings and the office hours and asking me and getting feedback about the different parts of their project. That's great. I expect those students will probably do quite well because they've already come in and shown me their work, and we say, okay, well, this is pretty good, but here's some advice, here's some feedback I have for you. Maybe you want to think about doing this. And then when those people make those changes to their final project, it's probably going to be pretty good, right? And you don't have to take my advice, right? If you say, nope, I think this is the best way to do it, go ahead. But some students are getting feedback. So by all means, if you are confused by the project, if you are stressed out by the project, come in and get feedback from me, right? Come into office hours, ask me questions. I will sit down, look things over with you, and see what we can do for you. Okay. I think with all of that said, I think we're ready to get into estimating things, right? And these things sound as simple, but they're much more complicated than they seem, right? So there's kind of two parts of statistics. There's the descriptive statistics. So in the earlier chapters, we looked at descriptive statistics, and that's kind of summarizing data using tools. So you make a visual. That you're not really doing anything new when you make a histogram, when you make a pie chart, when you make a box plot. You have, you're doing some organization, you're making some decisions, but you're not really creating any new information. You're just coming up with a better way of describing that information. That's why it's descriptive. So if I give you a data set and you come back and you say, here's the mean, here's the standard deviation, here's some visuals, that's great and it's insightful and helpful, but it's descriptive. You're just describing something that you witnessed. You didn't really create anything new, right? So then there's the inferential statistics where you take information and you create new information from it, if that makes sense, right? That's where you start making predictions, where you start making interpretations, stuff like that, right? So we start getting into the inferential statistics that involves using sample data, and you all have sample data, to form generalizations or inferences about a population. So we can start, before we could say 80% of the sample data that we got says that students support a full tobacco ban, right? That's the kind of thing we could do before. We want to be able to have, instead of just describing things that we saw, we want to create some new, more powerful tools that will allow us to do, bigger things, basically. So some of our activities, we will use sample data to estimate values of population parameters, such as proportion or means. Those are two totally separate things. Remember, a mean is what the mean is. We add up a bunch of values, divide by the number of values. A proportion is when you're saying what proportion of people support a full tobacco ban, right? There's no mean there. You're looking at a percentage of people who have a certain belief or a certain opinion, right? So remember the difference between means and means and proportions, because they're going to come up and you have to be able to know which tool to use. That's a thing that I see hold a lot of people back in the statistics class, is they're still hung up on trying to figure out the difference between quantitative and qualitative. And then if you're hung up on that, you're not going to know which tool to use when, and it just sort of snowballs into this big mess. Okay. The other thing we'll do is test hypothesis or claims made about population parameters. So we're going to very heavily be using probabilities. The good news is you're not going to have to calculate them all that often. StatCrunch will do that. But you're going to get a probability, and that probability is going to lead us to make conclusions about the populations that we are trying to study. Okay? So remember here, that, sorry, my dog was barking. My dog almost never barks. Remember here the difference between a population and a sample, right? A sample is the group that you went out and you found that information. And then there's the population, which is the whole group that you're trying to study. So in other words, I send you all out. I say, each of you go find 100 Ventura College students, ask them if they support a full tobacco ban. Well, you each conducted a sample of 100 students, but we still don't know the real value of the whole population, right? And the reality is we'll never really know, right? We'll never really know that value, but we can come up with a pretty good argument about what we think it is, okay? But that's a really important concept that we're going to be developing today and in the coming weeks, is this idea between I'm looking at a small group, a sample, but I really want to know about Ventura College students at large. Like when we go sample 100 students, it's not like I really care what those 100 students think. I'm not going to go before the academic senate and say, these 100 students that I asked, they are the opinions that matter, right? They're not special. We ask those 100 people because our ultimate goal is to figure out about the entire population, right? Which again is always kind of this unknown. I think people think that, when we do the work, we figure out the real population parameter, and we kind of use our language loosely. But what we're really trying to get at is you're trying to come up with your best guess. It's not like in real life, there's not a back of the book where I can look it up and go, okay, I think 81% of students on campus support a tobacco ban. And then I look in the back of the book and it says, nope, actually it's 79.8. That information doesn't exist anywhere. That's why we use statistics to come up with it. So just remember that if what I just explained makes sense to you, you're going to have a much better understanding of this discussion that we're going through. Okay? All right, so let's get some concepts out of the way. We have this idea of a point estimate. Okay, and you kind of this one's kind of obvious. Once you understand what a point estimate is, you'll be able to pick those out pretty easily. But what we want to understand is why the point estimate isn't good enough, right? Why can we do better than the point estimate? So the point estimate, and again, remember, right now we're talking about proportions. It's a similar but different ballgame when we talk about means. We have to use different tools along the way. We have to use different work, but a lot of the concepts will carry over. So if you understand the stuff we're talking about when we're talking about estimating a population proportion, it will make sense to you when we talk about the population mean. Okay? So a point estimate, the sample proportion, and we usually call it like p hat, that little caret above the p, we usually call that a hat, right? So p hat is the best point estimate or single value estimate of the population proportion. Okay, so right, and then here's our formal definition. A point estimate is a single value or point used to approximate a population parameter. So it's like your best guess, but it's usually going to be wrong. It's going to be in the right neighborhood of the right thing, but it's going to be incorrect. Okay, and I'll show you. We'll go back to a picture we looked at last time in a minute, and I'm going to reinforce that idea of what we were talking about, and hopefully you can start to put all these pieces together. Okay, and then they tell us here, the sample proportion p hat is the best point estimate of the population proportion p. Now, what does that mean? What am I actually saying when I do this? So imagine we're on campus, we're in a classroom, and I say, you know, imagine it's whatever it was 5 years ago, whatever, where we were doing the work on the tobacco ban, and I say, okay, I want all students to go out into campus and conduct a simple random sample of 100 students, and you're going to ask them if they support the tobacco ban. Then you're going to come back and we're going to report our findings, right? So let's just say that the true proportion is 80%. 80% of students support a tobacco ban. Again, we'll never know that. We don't have like a magic genie where we can rub the lamp and then it's going to tell us, oh, here's the true proportion. Like, we don't know, but we're trying to get to that. So some of you will come back with the result 80% for your proportion, right? But many of you are going to come back with a proportion of 81%, 79.7%, 83.4%, 74%, right? You're going to get values that are around 80%, but not exactly 80%. Now, it's going to look like, let me write down what page I'm on so I can keep bouncing back and forth. 319. Okay, where was that one I want to look at? Because I think it's one of the most important pictures in the book as far as being able to easily understand what it is, these ideas that we're looking at. Where is it? Was that it? Oh, almost. We're almost there. Actually, that's for the mean. Did they do the same for proportions? Don't remember. It doesn't matter. We can use this picture because it's basically the same thing. We'll kind of look at both of these. Okay, so these are for means, but you get the same idea for proportion. And this is page, what, 266? Okay, so what happens is you all go out and you conduct samples. So we would have, theoretically, we'd have 40 samples, right? 40 people, each conducting a sample of 100 students. You each would come back with different data. Your data likely is going to stack up like this, right? So imagine this is 80, right? The imaginary value that we don't really know, but, you know, just suppose the unknowable value is that actually 80% of students support a tobacco ban. So you're going to find 80 right in the middle. Some of you will get 80 exactly for your proportion. Other people, you're going to stack up right around 80. We're going to see 81s and 79s, and down here you might get like an 87, and down here you might get like a 72. But the closer you get to 80, the higher you're going to see these values stacking up, which means that you're for the most part, you're all going to be pretty close, right? Every once in a while you get an outlier where someone just happens to pick, you know, the wrong people. Maybe they're conducting their sample over by an area where people come together to smoke, so that's going to skew their results quite a bit. But you can see how everyone would get values that kind of pile up around 80. But let's say you don't know those other samples. The only sample you know is the one that you went and occurred. So we haven't shared data yet, and you go out and you asked 100 students, and then you come back and you say, yeah, I measured 77% of the students in my sample said they support a tobacco ban. And then I ask you, right? You don't know any other information. You don't know this imaginary 80% that we somehow magically know. And I say, okay, you went out, you took a sample, and you measured that 77% of people support a tobacco ban. And then I ask you, what is your best guess for the population of people that support a tobacco ban? We know for a fact that 77% of your sample supports a tobacco ban. But we don't care about that 100 individuals. We care about the 10,000 VC students because they're all going to be subject to a new tobacco rule. So we got to make sure that we are picking a rule that, you know, the student body at large cares about the population, not just the 100 people we asked. So if I put you on the spot and said, okay, all we know is that you went out, you measured 77% of people in your sample support a tobacco ban. So what is your best guess for the entire population? That is all VC students. What do you think proportion of those students support a tobacco ban? Well, it makes sense that you would say, well, my guess is 77% because that's what I measured, right? And you don't have any other values. So your value might be a little low. You might be like right here on the chart, but you don't know that because you don't have all these other data values. We haven't shared all the other sample data yet. Okay, so when we talk about a point estimate, it's a single value. I'm picking a single number, and that's going to be my estimate for things. And you can get it really easily. It's generally going to be the thing that you measured. So your sample proportion that you measured will be your point estimate for the entire population. It makes sense. If you measured 77% and I say, okay, what do you think about the school at large? You're going to go, I guess I'm going to guess 77%, right? You're going to go from there. So let me go back to where we were, 319. So that's what we mean when we say the sample proportion P hat is the best point estimate of the population proportion P. But here's the thing, you're probably wrong. So that's why we call it an estimate, because it's probably not going to match the exact value, but it's probably in the neighborhood. You measured 77%. We somehow magically know that the true proportion is 80%. Well, that's pretty close, right? You did pretty good. You got in there. You got close to that number, right? It's probably close enough that it's not going to confuse us, right? It's not going to, if the difference between 80% and 77% isn't going to cause us to make a different decision, right? So it's kind of in the right neighborhood. So that's our best point estimate. But we have to realize that point estimate is probably incorrect, right? So now imagine that you've just made your point estimate, right? You went out, you did your survey, you came back, I started talking to you, I put you on the spot a little bit and made you give me a point estimate, and you said, well, I think it's 77%. And then I went around the room and I did that with each person. And then the person behind you said, well, I got 79%, okay? And then the person behind you, well, I got 81%. And the person behind them, well, I got 80%. Again, we don't know that 80% is the true value because you never, we don't get to read minds or whatever. We never really get to know this. And you go around the whole room and we listen to everyone's results. Well, after hearing that, you might go, well, I think my 77 is actually a bit low. I think that maybe now after hearing the sample values that everyone else got, I think maybe the true proportion for the whole population is a little above mine. And maybe there's someone in the room who got 84%, and they're thinking, I think my value is a little high. Most of the values that I heard were below 84%. So we're kind of getting the sense that somewhere in that middle value is probably a better estimate than our point estimate. So a point estimate is real easy to find. You get it automatically. It's your own value that you figured out. But it's also not a very good one, right? And that tends to be how statistics works, is in order to get the really good work, it's harder to do, right? So a point estimate is easy to find, less helpful overall, right? It's kind of helpful, but you can't rely on it as much as we can rely on a better measurement. So then we're kind of stuck. Right? What are we going to do? We got 40 people in this room, and we kind of see where that we're getting 40 values that are kind of in the neighborhood of, 77 to 83, and then there's a couple values a little bit further out. But we go, okay, well, but what do we do with that? How do we come up with a better value for that? So, when we go around the room, we'd see something that looked, when we asked everyone, it's going to look like this. You've all given me your proportions, and they're piling up like this. Now, we can just say, well, right in the middle, I think it's 80. But the reality is probably that's not a perfect way of doing it either, because it's actually unlikely that you're going to get this perfect normal distribution, right? 80 might actually be right here off to the side a little bit. So if we just conclude that our answer is 80, we're still probably going to be wrong. So what do? We're going to create an interval. Remember intervals from algebra where you'd have the interval from 2 to 4. So that would include all numbers from 2 to 4. 2, 3, 4, 2.2, 2.78, 3.145769, like all those kind of numbers would be in that interval. So that's what a confidence interval is we are going to create an interval based on a confidence level and we can say, I think the true proportion is in this interval. I think it's sitting in there. I don't know exactly what it is. And that's kind of unsatisfying because, just from a cultural standpoint, we're kind of very spoiled, right? In general, we want what we want. We want it now. I don't want to hear about any kind of like disagreements or anything. Just give me what I want. It's kind of how we do it. You want a number, right? When I go back to academic senate and say, here's what we think. We think that the true proportion of students that support a full tobacco ban is between 78% and 82%. That's unsatisfying for many people because they're like, just tell me the real answer. And the problem with statistics is we don't really know the real answer. We're pretty confident it's between 78 and 82%, but we don't know where it is. It could be 81%. It could be 79%. Now, for something like the tobacco ban, doesn't really matter. Anywhere between 78 and 82%, we're probably going to say it's pretty overwhelming, right? These days, you can never get anyone to agree to anything on the level of 80-something percent. That's pretty overwhelming. In fact, we just saw this for those of you who live in Ventura. So you know how the downtown has been sectioned off? You can't drive through the downtown. And it's actually really pleasant to go to downtown now. Things are spread out. You don't have people driving by. You can just walk across the street. People walking their dogs. There's plenty of room. There's people to spread out. But the city council did a survey. Do you think we should leave it this way where cars can't drive down the middle? And it was overwhelming. It was like 85% of people said, keep it how it is, right? We don't have to drive down Main Street. I can drive on Thompson or any of those side streets over there and get around. And that's basically what the city council said. Is they're like, we never see anything with 85% favorability, so I guess we got to do it, right? So that's pretty high in a very sort of confrontational time that we're all sort of living in, where the issues tend to get confrontational. People really stick to their guns and don't want to talk things out and just want to sort of yell at each other. But in that case, if I go to academic senate, so switching back to the tobacco ban, if I go in there and say, yeah, we think it's between 78 and 82% that people want a tobacco ban, that's what the students want, we're probably going to go with it because that's overwhelming, right? But what if I went and said, well, we're pretty sure that the number of people who support a tobacco ban is between 45 and 55%, right? And then we go, well, I don't know, which is it? Then we don't even know if it's a majority. It could be 47%. It could be 52%. So there are times when the confidence interval can be it still is like, okay, I'm fine with the fact that it's an interval because any of the values in that interval are still helpful. But if the interval is in a part where it may make it harder to make those kind of decisions that you want to make. So let's talk specifically about what that is. Where are we? Here's our definition for a confidence interval, sometimes called an interval estimate, but really not. It's called a confidence interval. So a confidence interval is a range or an interval, right? You're probably more used to the word interval from algebra. A confidence interval is a range or interval of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated CI, confidence interval, right? So, Imagine that you're trying to estimate something and you can't hit it perfect, but you can narrow it down to a range, right? Let's say that, sometimes students come up and talk to me, or in office hours, we get in conversations and stuff like that. And it's usually about math, but sometimes people will, bring up stuff. Oh, I missed the test because of this and that. And sometimes people share stuff. So they're giving clues about themselves, right? So, imagine that I'm talking to a student, and that student, like, this is a common thing I hear at the beginning of the semester. A student comes up and says, I haven't taken math in a few years. It's been a while. Well, that could mean a couple of things, right? It could be the last time that student took math was as a junior in high school. But if they're saying a few years, if they say I haven't taken math in a few years, then I'm probably going to guess, well, you're probably at least like 19 then, because if you haven't taken math for multiple years, you've probably been out of high school for at least a year. So I can go, well, you should be like at least 19. And then they talk about like, oh, yeah, I tried to rent a car and I can't rent a car yet because you have to be 25 to rent a car. And then it's like, okay, well, but you're younger than 25. So I now have an interval. I'm pretty confident you're between 19 and like 24 years old, right? Not that it matters anybody's age, but what I'm saying is this is how you construct an interval. You go, okay, there's an interval there. I'm pretty sure you're at least this old, but you're not older than this. And then you sort of can make an estimate, and you would say, well, I'm pretty sure this person's between these ages. That's what we're going to do, but with proportions and means, and say, I think the true proportion is between these two values. I don't know where it is in there, right? I don't know if this person is 19 or 20 or 21 or 22 or 23 or 24, but I think they're in there somewhere, right? So that's what our confidence interval is. We're going to be real confident that the proportion is in there somewhere. There a lot of times students will take the confidence interval and just take the value in the middle and say, well, then wouldn't it be the thing in the middle? No, because the thing in the middle is the point estimate, right? You're sort of working backwards. We don't know that the true value is right in the middle of our interval. So don't make that mistake. I always see 2 or 3 students do that, where they're like, well, here's my interval. The thing in the middle should be my true value then, right? No, we don't know that. Just like we don't know that person's age between 19 and 24. We're pretty confident it's in there, but the person could be 22. They could be 23, 24. Who knows, right? So you get a range of values. Okay, then we have this thing called a confidence level. The confidence level is the probability. We call it 1 minus alpha. I'll talk about that in a second. But it usually looks like 0.95, which we would interpret as 95%. So we can say you'll use this term and you'll hear this term get used. We are 95% confident, right? We have a 95% confidence interval. Sorry if you can hear that noise. Someone's doing yard work outside. So we're going to, you can talk about like there's a balancing act we're going to do with confidence intervals. The more confident that I am, the wider our interval gets, which is pretty intuitive if you think about it. Like if you just take an interval and you're like, we kind of think that the value is in here. What if we make that value, that interval bigger? Now I'm even more sure that the true proportion is in there. What if I make it wider again? Now I'm really, really sure that the true proportion is in there. And the more we shrink that interval, the less confident we can be that the proportion lies inside that interval, right? You just think of it. As you shrink it down, it's less and less likely that the proportion's in there. So you're always playing this balancing game. If you have a really wide interval, that's not as helpful, but I'm really, really confident about it. Vice versa, I can make a really small interval that is more helpful to us, but I'm not really sure if it's right or not, right? So imagine the tobacco ban. Imagine I go into academic senate and I say, I am 98% confident that the proportion of students that support a tobacco ban is between 14 and 86%. that's not going to be very helpful, right? I'm really, really confident that the proportion is in there, but everyone in academic senate is going to look at me and go, what are we supposed to do with that? Between 14 and 86%, that could be anything. That could mean 15% of students support it. It could mean 85% of students support it. Well, which is it? So see how that interval is not especially helpful, but we're really, really confident in that interval. I mean, you could take it to an extreme and say, I'm 100% confident that the proportion of students who support a tobacco ban is between 0 and 100. Right? I can be 100% confident of that. But that's not helpful at all. Right? So that's kind of the extreme. So what you want to do is create a balancing act based on your problem of how important it is, how important is your confidence in the problem versus how helpful is your interval. And this is something that you might have to play around with a little bit in your projects. Now, we do have a default. We usually go with 95%. If you're 95% confident, that usually gives you a reasonable interval. And at the same time, being 95% confident about that is pretty good. That means you're going to be right 19 times out of 20. But 1 out of 20 times, you're going to be wrong. And remember, that's how statistics always works. Like, a lot of times people think that a high probability means something is guaranteed. You saw people do this with the Trump election. Right? So we're not going to get into politics here, but I'm going to talk about the statistics of that election. Going into election night, so the day of election, right? Because I was watching all this stuff when it happened. Hillary Clinton was given an 80% chance to win, but that also means she had a 20% chance to lose, right? That's 1 in 5. That means if you hold 5 elections, she wins 4 times, Trump wins once, right? That's how percentages work. So what people interpret that as when they see Hillary Clinton had an 80% chance to win, that just people go, oh, well then she's going to win every time. It's like it's guaranteed 80%. No, that's 4 out of 5. 80% is 4 out of 5. That means she loses 1 out of 5, and she lost the 1, right? So when you see these kinds of probabilities, people tend to try to make it like it's set in stone. But as we saw with that election, it was not set in stone, right? Trump had a 20% chance of winning, and he won. So that's what we have to do with the confidence intervals. If you use 95% confidence intervals, you'll be wrong 1 time out of 20. Rough on average, right? Roughly. That's like the expectation if you do this a lot. You can use a 90% confidence interval, but that's not terribly confident. You can use a 99% confidence interval. I mean, you can use whatever confidence level you want, but those are the common ones given right here. These are real common. 90, 95, or 99. We almost always go with 95%. Like, that's going to be the common thing we do. You go, well, what about being 99% confident? Don't I want to do that? Sure, that's better from a confidence perspective, but it also means in order to get that extra confidence, you have to increase your interval. Well, a bigger interval may not be as helpful. If your boss is trying to, figure out, some percentage about the company, what percentage of our workers are going to join the strike, and you're like, you can say, well, it looks like it's between 72 and 80% versus, well, it's between 50 and 80. That's a much bigger interval. It's harder to know what to do with that, right? So that's the balancing act you play. As you get more confident with your confidence level, your interval widens, which means you have less of an idea where that true proportion actually lives, right? And again, the extremes are... just go back to the 2 extremes, and it helps you remember this variation. The most extreme is, I can say, the proportion of students who support a tobacco ban is I'm 100% confident it's between 0 and 100%. Like, I don't even have to do a survey. I can make that statement, but that's not helpful, right? I'm 100% confident, but no one's going to benefit from that result. The other extreme is we narrow it down to a single point, your point estimate, which is probably in the neighborhood of the right answer, but is almost assuredly off by a little bit. It's almost probably wrong, right? So we want to get in the middle where we can be real confident about an interval and say we think it's in here. Another thing that affects these confidence intervals is, are we talking about something like the tobacco ban, where it's probably not lives on the line? You could say, well, smoking involves health, but okay, if someone on campus smokes in a smoking shelter, it's probably not going to give you cancer, right? Assuming it's outside and stuff. So probably 95% is okay. If you're doing a safety check on a new plane that you're developing at Boeing, which is going to be carrying hundreds of passengers at a time, is 95% confidence level good enough? Probably not. If lives are on the line, you probably want to increase that confidence level so that people aren't dying unnecessarily. But it just depends. You have to do that balancing act, okay? So here's an example. Here's how you could state a confidence interval. So the 0.95, or a lot of you, a lot of times I too, will call this a 95% confidence interval. But remember, the decimal representation of that is 0.95. So either way, the 95% confidence interval estimate of the population proportion P is between 0.828 and 0.872. So you can report back to your boss, whatever this is, or I could report back to Academic Senate and say, we think that the proportion of students who support a tobacco ban is between 82.8 and 87.2%. Okay, good. Then we can say, okay, well, that's pretty overwhelming. I guess we're going to go with that. All right, now you have to be careful. These are red flags for the project. So make sure you say this correctly, because that's one of the things that cues me into when I'm watching your project and you use the incorrect summary or statement. You say a thing that's just incorrect. That's a red flag to me that maybe this person doesn't know as much statistics as they kind of are presenting. Okay, so make sure you're careful with the language. Make sure you're being careful with how you summarize things. Feel free to talk to me in office hours, whatever you need to put those together. But especially with hypothesis tests, I see students mess up their conclusions all the time. They've memorized the buttons to push in StatCrunch. They get their numbers, and they completely mess up their conclusion. That's going to lead me to believe that you don't understand what a hypothesis test is. So we'll get to hypothesis tests in a week or two, a couple weeks. But right now for confidence intervals, I've said that's one of my big things. Like if you're going to get an A on the project, it means that you've done all the other work really well, but your interpretations and your conclusions are solid. Okay, that's what gets an A in the class. If you're just a button pusher and it's clear to me that you don't understand what's going on, those are like DC grades depending on all things. There's a lot of things that get graded in those projects. But so if you're shooting for an A in the class, this is what you want. You want your interpretations and your conclusions to be solid. So here's how we could say this. Let's say we found a confidence interval, a 95% confidence interval that's between 0.828 and 0.872. We can say we are 95% confident the interval from 0.828 to 0.872 actually does contain the true value of the population proportion P. This means that if we were to select many different samples of size 1007, and because that was the sample size for this problem, and construct the corresponding confidence intervals, 95% of them would actually contain the value of the population proportion P, and 5% wouldn't. So out of every 20, that's one would actually not do it. So if we had the whole class do confidence intervals, we'd probably get 2 people whose confidence intervals were incorrect. Like it didn't actually contain the true proportion, because that's one out of 20, right? 2 out of 40. So now you don't actually have to say that whole thing, but you usually will say, like, you want to know this top sentence. Get used to that one. We are 95% confident that the interval from whatever to whatever actually does contain the true value of the population proportion P. And then, of course, you're going to change that to be about whatever you're talking about. So you might say, we are 95% confident that the proportion of students who support a vaccine mandate is between 58 and 62%. Right? So something like that, using those using that kind of language, right? That's the right way to do it. The wrong way to interpret it is there is a 95% chance that the true value of P will fall between 0.828 and 0.872. Now that sounds like the same thing, but it's not. There isn't a 95% chance that the true proportion value is there. The true proportion value is either in your interval or it's not. There's not a 95% chance of that. We just don't know the value, right? Also, 95% of sample proportions will fall between this. That's wrong as well. So those are incorrect interpretations. So get used to that statement. We are 95% confident that the interval from A to B actually does contain the true value of population proportion P, whatever your proportion is. Don't write population proportion P. Insert the information from your problem. Like I just gave the example of vaccine mandates, right? Whatever it is. And we'll talk about means when we get to that. So yeah, and they even caution in the book, know the correct interpretation. If you use the wrong language, I know a lot of times people think like, why is my math teacher making such a big deal about language? This is an English class. But once you learn enough of this and you're comfortable with this, you look back and realize like, oh, what I was saying didn't even make sense. It was like totally illogical and oftentimes just mathematically wrong. So I get it. On day one, if you read these three things right here and you can't really tell the difference, that's okay. You're just learning about these right now. But in a week or two, if you come back and read these, you should be able to go, yeah, this one up here, that's right. And these two, yeah, that's not even what a confidence interval means. Why would someone even say that? But in the beginning, when you're just learning, it's easy to say the wrong thing, right? It's like when you learn a language, when you first learn a new word, you might mispronounce it a few times, but then later on, you know how to say that word correctly or whatever it is that you need to do. Okay, so I think that makes a lot of sense to stop right there because that's kind of where the topic ends. This is an example of, so actually let me take 2 minutes to just describe this graph and then we'll pick up from here next time. So this is what it means to be 95% confident, is that let's say I sent 20 of you out and said, find out if people support a tobacco ban on campus. And you all came back and you each constructed a confidence interval, right? And you've got your confidence intervals here. Let's say the real value, again, we would have to be magic to know this, but the real value is 0.9. See how it falls in a bunch of your different intervals? This is an interval that each of you students will come up with. See how 0.9 is in almost all of them? But remember, it's not in the middle, right? It's towards the middle for some of them, but notice how it's on the end of some of them, but still inside the interval. But there's this one that missed. One person went out and they didn't realize that they were interviewing people around a place where people go to smoke. And so then they got a whole lot less support for a tobacco ban or whatever. Here's the 5% right here, the 5% that actually don't contain the true proportion of 0.9. So out of 20 of you constructing a confidence interval, a 95% confidence interval, we would expect one of you to not have the true proportion in there. It's still kind of close, but not really in that interval that we came up with. That's what we're talking about, okay? Okay, so I'm going to leave it off there. Office hours start right now. So anybody who wants to, or technically in a minute, anyone who wants to stick around and talk to me about the class or other classes, or it's office hours, so any class, you can talk to me about any class, you're welcome to do that. Okay, thanks everybody. All right, and then let's see.